Welcome back to Young Engineers of Today. We had a good weekend because we are about to continue with Arduinos, multiple LEDs now. We made one blinking LED, but it's kind of boring. We want to do more. And what's the most direct way to do more? Well, it's to make more LEDs blink. Because why not, right? Why not? I know, right? So that's what we're going to do today. Now, more than just having more LEDs blink, it actually teaches us a couple other important aspects of programming, and helps to sort of put the interplay between hardware and software maybe a little bit clearer, in a better light, in a clearer light. That's the hope at least. So what we're going to do is we're going to go over how to build the circuit first, and I'm going to explain all that kind of stuff, and then we will go into the software side of everything and the coding side of everything, I suppose, and I'll spend a fair amount of time explaining that as well. So we're probably looking at about 2 classes to get this circuit done, just because of all the new stuff and the fact that it's just that much more complex than the other circuit. But I could be wrong. Who knows? Who knows? But let's start this off with a little bit of review. So you guys know what these are, right? Yep. Yeah, I don't have to waste your time with questions like those. You know about these, right? Ugh. How about why do they have different colored bands on them? Mm-hmm. Exactly, yeah. Yeah, so you guys are pretty well aware of that. All right, how about the software side of things? Let's see here. Let me go ahead and... Do you guys remember the 2 things that must be a part of every Arduino program? I'll give you a hint. They both start with that. That's one of them. Yep, that's both of them. Void setup and void loop. Those are the backbone of an Arduino program. All Arduino programs are going to need to have those 2 functions. They can have more than those, but they need to have those 2 functions. As a side note, no, never mind. Let's see what else here. I'm going to go into a little bit more detail about this, since I didn't really spend much time on it. Does anybody remember what that line does? Not quite. Not quite. Yeah, it does, Jean-Marc. You were correct. Yeah, basically, Jacob. No worries, Noah. Yeah, so we're declaring a variable. We call it LED pin. Oh, that's fun. We call it LED pin, and we set it equal to the number 13. Now, the first part in the beginning, int, means that this is a variable of type integer, which means it's always going to be a whole number. Whatever LED pin holds, it's always going to be a whole number. It could be 5, it could be 1, it could be -2, it could be 3 billion, it can't really be 3 billion for reasons that I might explain later. It could be 30,000. It might actually be 3 billion, I can't remember. Whatever, regardless. It could be negative, 6,536, whatever. Just as long as it's a whole number. It could be 0, but it can't be 0.5. because then depending upon the compiler you use, that's going to be either 0 or 1, which that gets a little wonky. But anyway, too advanced. No, it's information that's not relevant right now. At some point I'll probably explain it, but it's when explaining why it can't be like that, it's not strictly necessary to know, and it might just be additional information that might muddle things up a bit. So basically, this whole line has 3, maybe 4 parts to it. We're setting up the type of the variable, in this case integer. We're giving a name to the variable, in this case LED pin, and then we're setting it equal to a value, in this case 13. The 4th maybe part is the semicolon at the end, which is required for the end of pretty much all statements in Arduino's programming language. So those are like the 3 main things in order to have a variable created and assigned to a value. Now you can do them separately. You can create a variable and then later assign it a value. But there's one thing which you shouldn't do, and that is create a variable without assigning it a value and then use it. Like if we were to do this, for instance, and this is sort of made up pseudocode, so don't worry about it. It's not quite worse than that, but it's not recommended. Look at my lovely, lovely code. Lovely, lovely code. So why might this be a bad idea? Because the computer doesn't know what LED pin is. Okay, yeah, no declaration. Well, there is a declaration, but there's no initialization. The thing is, with this right here, we've created a variable, and we've given it a name. But computers, in the interest of making things as quick and efficient as possible, are a little bit lazy in the way that they handle data. So when a computer is done using a variable, what does it do? In essence, all it does is it just forgets the association between a name and a place in memory, because that's all a variable is, right? It's just a place in memory. It's like okay, here at address 5, we're going to hold the number 13. In the future, though, anytime I want to reference address 5, I'm going to call it LED pin. And it's just this block of memory that's reserved for whatever LED pin is holding. So let's say the program ends, and the computer doesn't need to do it. The computer doesn't need to do anything with LED pin anymore, and it doesn't need to use LED pin anymore. In fact, it doesn't need LED pin anymore at all. So in computer parlance, the variable is destroyed, because that's actually a super metal way to describe it, so I kind of like it. But the variable is destroyed. All that simply means is the association between LED pin and address 5 is lost. It doesn't mean anything else. That slot of memory is still filled with the last value that LED pin was, because it doesn't like blank out any information in memory or anything like that unless you explicitly tell it to. It's like if you had a box and you labeled it Christmas stuff, and you put all your Christmas stuff in there, and you didn't need to use the box anymore, and so you just ripped the label off and stuck it in the garage somewhere. That box still holds Christmas stuff, it just doesn't have that label on it anymore. It doesn't have that association. So when somebody asks you to go find the Christmas stuff, let's say you have a super short memory and you go, I can't find a box that's labeled Christmas stuff. So you might slap a label on another box and empty it out and fill it up with Christmas stuff, because that box is going to be filled up with whatever you last put in there. So when we initialize a variable, or excuse me, when we declare a variable but we don't initialize it, it's filled with whatever value used to be, like, was last put in there. So LED pin in this case could be filled with the number, 3,475, or 2, or -8. Whatever the value is, it's not what we want. You can't assume that it's going to start at 0 or some useful value, because that is very rarely the case, unless you explicitly tell the computer so. Now, it's fine to declare a variable and then initialize it later in your code to some value that you may not know what the value is at that point in time. So you might say, like, okay, I'm going to create a variable here, and then like 30 lines down, I'm going to set it to whatever value the time is, or something like that. That's totally fine, just as long as you don't use it before then, because you're going to get some really weird behavior in a computer. So I just wanted to get that point across. This could print all sorts of weird stuff each time you run it, in fact, because it will assign LED pin to a different block of memory a lot of times, and that block of memory will be holding whatever was last in there. So, who knows? A small note on variables I just wanted to get across. Let's see here. That, for now, that's going to do it for reviews/side notes. Let's go ahead and get started on the lesson. Let's start building our circuit. Let me just see if there's anything else. Okay, I'm going to go to circuits.io. And here we are at circuits.io. Exciting, I know. And here in not a bad idea. Bookmark it if you haven't. I like typing it out, and Chrome saves the address anyway, so because I really like my keyboard. It's such a goofy thing to say, but I really do. Anyway, good to correct yourself. There's no worries that we got what you meant. Once you're here, chances are it saved your login. So just go ahead and go to Create, and then open Electronics Lab Hub, and then New Electronics Lab, just like we've done in the past. And it should bring you, once again, after it's done loading, a blank breadboard. Like so, and nothing else. That's perfect. That's what we want right now, because we're going to be grabbing a bunch of stuff. Well, we're gonna use a bunch of stuff in our circuit. Can we use the one from last time? Let's build one from scratch, especially because it's not going to be using the same pins as last time, and it's going to have a slightly different setup from last time as well. Okay, so here is the breadboard. Flat. Sorry. I'm going to go ahead and rotate my breadboard 90 degrees. Does anybody remember how to do that? Yeah, R, the R key, or R, or R. Can we eat it afterwards? I don't know. I don't recommend it. So I'm going to rotate my breadboard, and then I'm going to bring in some components. So just like last time, I'm going to bring in one resistor and one LED. Hold on, yep, here's the resistor. If it's in the name, it's got to be edible. Hard to argue with that logic, except you probably still shouldn't eat it. And then I'm going to bring in an Arduino. And I'm going to do my best to misspell it multiple times. And I'm going to rotate the Arduino, and I'm going to close out the components list. So now we got our 3 components. So far, so good, right? Let's check out the list of components that we've got. Well, we've got LED, we've got resistor, we've got some jumper wires, no surprise there. Got to make sure it's 330 ohm resistor, so let's go ahead and fix that again. So I'm going to click on my resistor, bring up the properties menu over here on the upper right hand side, and I'm going to change the resistance to 330 ohms, just like before. Perfect. All right, so everything seems okay now, except this is only circuit 1. Except, well, where are you? Here we go. We need 8 of them. Bum, bum, bum. That's the kicker here, is we need 8 LEDs and we need 8 330 ohm resistors in order to fully build our circuit. How we duplicate? I'm glad you asked. If you hold down Shift and drag a box, create a box, which you can use to select multiple things. Select both your LED and your resistor. Then you're going to hit either Control-C or Command-C, depending upon whether you're on a Windows/Linux or Mac computer. Control-C if it's Windows or Linux, Command-C if it's a Mac. Just once. And then you're going to hit Control-V, and you're going to notice that you're going to have a resistor and an LED following your cursor around. Just go ahead and click, hit Control-V again, click, hit Control-V again, click, and repeat until you have 8 of each. Boom. So now we have 8 LEDs and 8 330 ohm resistors. That's the crucial thing. That's why I changed the resistance of the resistor before I started copy pasting. Because we want to make sure that we don't copy, zoom out using the mouse wheel. We want to make sure that we don't copy a 1000 ohm resistor and then have to change the resistance on all of them 8 times. That just is more work. And if we can save work, we can be happy. All right. So now we've got our LED resistor pairs. I used Control-C and Control-V in order to copy and paste them. Just make sure they're both selected too. I held down Shift and dragged a box with a left click around them. It's not working. Okay. So you have both of them selected, Andrew? Oh, to zoom out? I know there should be another means to zoom. Hold on, I have to look up the keyboard commands again real quick. One moment. It doesn't seem that there's another a backup for zooming. You have to use the scroll wheel, unfortunately. Do you have one of those multi-touch touchpads? Control plus plus? Oh yeah, look at that. It's not listed in anything. Yeah, if you hold down the control key and hit plus or minus on your keyboard, that will also work. Thank you, Jean-Marc. I knew there had to be a keyboard command. Excellent. All right, so yeah, there you go. It's a little bit more unwieldy than a mouse wheel, but if it works, it's infinitely more wieldy than something that doesn't. It's an awkward way to put it. Anyway, so now we've got all our components. Woo-woo. What I'm going to do is I'm going to place them onto the circuit board. Oh, did you already knew that? You knew that the whole time? Well, sometimes. All right, so here's what I'm building here. I've got the cathode. Let's do this. I got the cathode of the LED hooked up to a resistor. And then the resistor is hooked up to the minus rail. I'm going to hook up the anode to pins here. But we'll do that in a moment. But for now, just have the cathode hooked up to a resistor, and then the resistor is hooked up to the ground rail. And then just do that one by one. Exciting, I know. But unfortunately, this is one of the nuisances about things like 1, 2, 3D circuits. Whoops. What do you mean to appear? Like, how do you did you drag them out of the components box? Yeah, drag them out of the components box and then copy paste them. Spacing them out so that they're two holes apart from one another, which is not a necessary thing, but it creates a sort of consistency aesthetically, which is nice. Yeah, it is satisfying. So there we go. We've got our 8 LEDs and our 8 resistors hooked up right now. Now, you know, for funsies, you can also spend some time changing the color of the LEDs if you're so inclined. You're by no means required to do that, though. Switch these around. That was the first thing you did. There you go, perfect. So now I've got my little LED rainbow going on here, and I've got my Arduino over here to the right, left, to the left. So we want to ensure that we're going to have independent control over all 8 of these LEDs. So we're going to use 8 separate pins on the digital side. However, first things first, let's hook up the ground. So I'm going to do the thing that I always do, where I start drawing a, hold down Shift to create a box, and like Shift and then left click to drag to create a box, and then, or you can Shift and click each of them individually, and then Control C and Control V. Okay, so let's hook up the ground first. So what I'm going to do is I'm going to create a jumper out here. Now I'm actually going to head out this way. Why, you might ask? Because I'm going to left click once here. I'm going to create a bend in the wire. Amazing, I know. And I'm going to left click once here and create another bend in the wire. And then I'm going to finish the wire out down there. Bam, black wire. Is this necessary? No, but it does help clean up the design a little bit, so you don't just have like straight wires flying everywhere. So now we're going to hook up the power to each of our LEDs. If we need 8 separate slots, we're going to need 8 points that work on here. I'm going to start at 2. The reason we don't start at 0 or 1 is because they're reserved for data transmission on the Arduino. So we're going to start at 2 so that we can give ourselves enough space to hook everything up. So I'm going to bring out the wire a little bit and then go down pretty early on and then move back out towards the side and bam. Do a little bit of wire correction. And I'm going to color it blue just because it's hooked up to a blue LED. Then I'm going to do that same thing with 3. Just go to the next one up. Bam. Keep that one green. Do the same thing with 4. Make this one yellow. And then 5. You see where I'm going with this. Just go ahead and spend some time hooking everything up. And then 6. Seven, 8. And your last one should be on 9. Once that's done, you can see here I've got 8 jumper cables, 8 LEDs, 8 resistors. Well, I've got 9 jumper cables because I've got my ground, but 8 LEDs, 8 resistors. And our circuit is, for all intents and purposes, complete, and it's very colorful. So I'll give you guys a minute to do that once you've got a circuit that looks more or less identical to this, albeit obviously with maybe your own personal touch on it, just as long as it's hooked up to the same slots on the Arduino, go ahead and raise your hand. Okay, got a couple of hands. Make sure until we've got more or less everybody, because we're looking at a little bit less than half the class right now. Still waiting on a few people. No worries, don't rush. Just want to make sure that everybody's on the same page. You don't have to. No, I just did that for funsies. Also, don't worry about what I'm doing here. Just making a quick buzzer. Okay. Yeah, just one more minute and then we'll move on. Excellent. All right, well, let's go ahead and get started on the software side then, because the hardware side is good to go. So open up my notepad again, and let's go ahead and do our void setup and our void loop. Don't forget your curly brackets too, because those, again, denote what goes in the void setup and the void loop. Now, I'm going to do a thing. I'm going to do this code, and I'm going to do it entirely the wrong way. And when I do this to drive a point home about this new concept and how it could be useful. So get ready, because this is going to get long. Okay, so you remember how we did the end LED pin equals 13. You don't necessarily have to type all this out along with me just because it's going to be so much typing. Well, that was a good start. However, we've got more than one LED now. So let's go ahead and fix all that business. And we'll fix all that business. And look at that. So far, so good, right? And then we have to go like pin mode. And we'd have to do the same thing. Oops.
Caution.
Yes, I know, caution. This is already starting to wear on me. Okay, and then we're going to go... No. Like I said, this is just to prove a point. You can already see where I'm going with this, right? Yeah, this is a lot of typing. So far, what we've created is something that is identical to our first program, except adapted to use 8 pins. Well, almost. Missing one. But this is kind of gnarly. Like, that's a lot of repeating, and that's kind of annoying. There's got to be a better way to do this. Well, thankfully, there is. In fact, there's a way that reduces this. Yeah, this is a lot of work. There is a way that makes this so much easier for us. We are about to employ the power of the for loop. I dramatically, clenched my fists as I announced that. Because life's got to be full of a little bit of drama, right? Anyway, we're about to leverage the power of the for loop. But first, I should probably explain what the for loop looks like and how it works. So, you guys remember the loop from Scratch, right? Drama alert. Yeah. I'm sure you guys do. Oh, God. Keem, please no. No Keem, please. Keem, I don't often keep opinions about things, but Keem is just straight up not a good person. He's not a good person. Like, just not a good person. I've seen enough of Keem to know that he's not a good person. He might be a good person outside of his drama alert stuff, but what he does for a living, I cannot abide by. Anyway, so let's take a look at, yeah, but people take it seriously, and other people pay the price for it. That's the thing. When you put your face out there and you put an act out there, you have to be cognizant of how other people are going to take it. But that's where all the trouble comes in, regardless of whether or not he meant it. And I think that's a cop-out, to be perfectly honest. I think it's a cop-out. Yeah, basically. Yeah, anyway, sorry. Sidetracked. Well, in lives too. For loop. Looks like that. But there's some stuff missing. So let's go ahead and fill that stuff out. Yeah, I think that's probably for the best. So this is the basic structure of a for loop. This for loop will run 10 times, and it will execute all of the code that is in here 10 times. No, I'm just explaining this for now. I'll tell you guys once you want to start the code you want to start creating. If you want to write it down for your own personal notes, feel free, but this is not any part of the program right now. I'm just explaining what exactly is going on here. So this is what a for loop looks like. This is a for loop that's going to run 10 times. How might I know this, you might ask? Well, let me explain it to you. So there are 3 critical parts to a for loop. There is the initialization, there is the condition, and there is the math. These parts are pretty flexible, and they can be used in different ways, in different for loops, in order to achieve the desired effect, the number of loops that you want, and things like that. But basically, this is how it works. The first part of a for loop always declares a variable and sets it to a value. That variable is going to be used for the length of the for loop, and you'll see what I mean later. In this case, I said integer I equals 0. So I declared an integer, I labeled it I, and I set it equal to 0. You might go, why would you call it I? Well, to be perfectly honest, that's just kind of tradition, or there's a word I'm looking for that is kind of like, because it's what's been done before and because it's common for programmers to do this, but I can't think of it right now, of course, so I'm just going to say tradition. And you might say, well, that's dumb. Maybe we could name it something more helpful. You could, but generally, if you just want a loop to iterate a certain number of times, like maybe 10 times because you just want it to run 10 times, it can make your program easier to read if you use commonly accepted names, standards for this kind of. They're kind of like standards, although they're sort of unofficial standards. In this case, I is very commonly used as the iterator tracker variable for a for loop. Basically, the variable that keeps track of how many times a for loop is run. Fancy name for a variable that keeps track of how many times a for loop is run. Notice how we also set it to 0. You don't have to set it to 0, as we're going to see. That is not a requirement. But a lot of times it can be easier to keep track of how many times your loop is going to run if you started at 0. Why do we start it at 0 most of the time? Again, just because you get used to that as a programmer. Pretty much everything counting-wise starts at 0. You could start it at 1, but we started at 0. Just a lot of times you use a loop to iterate through things like arrays and stuff like that, and arrays start at 0. So if you want to utilize the power of the loop, you start at 0, and anyway, you get the idea. The second part, the condition, I is less than 10. As long as this condition is true, the for loop will execute at least one more time. So in this case, we start at 0. 0 is less than 10, so the loop runs. We start the next loop. As long as it's still less than 10, the loop will run. As soon as it becomes 10, it will stop running. Notice how I didn't say 10 or greater, because if your loop is operating properly, it should never have to go above 10. It should stop as soon as it hits 10 and then move on to whatever's beyond the loop. So all this stuff down here, la, 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 that'll start running after this loop has run 10 times. Then we've got the math portion. This one is I++. I'm sure you guys probably remember what the plus is, right? Did I ever explain it? I think I explained it. I may not have explained it. Anyway, if I haven't explained it, sometimes you just want to add 1 to a variable. I equals I plus 1. So if I was 0, then I would become 1. You're just simply adding 1 to the variable. Because a lot of these types of equations are very common in computer programming, this can also get shortened down to I plus equals 1, which is a shorthand for I equals I plus 1. Then, because specifically there are a lot of instances where you just add 1 to a variable, like a whole lot of instances, they created a shorthand for that, which is just plus plus. So plus plus is, at the end of the day, a shortened version of I plus 1. The reason why it's I equals I plus 1 is because that's how programming works. You have to assign this math to something in order for it to hold. So you would assign I plus 1 back to I. You would say, yeah, I equals I plus 1. Add 1 to I, and then stick that result back into I. So I becomes 1 larger. This only happens once because simple arithmetic doesn't loop at all, unless of course we put it in the loop. But then the loop does the looping and not the arithmetic. So you know that's not why that's necessarily happening. I plus equals 1. Again, plus equals is just a shorthand. There's also minus equals and times equals and divided by equals for the different arithmetic expressions. And it doesn't have to be 1. It could be 5 or 6 or 9 or 7, as my fingers typed, or 347 or whatever. I++, however, only adds 1. Only, ever. Ever, ever, ever. It will never add more than 1 to a variable. For that reason, there's also I minus minus, or variable minus minus. It doesn't have to be I. It can be like, you know, LED pin minus minus, or it can be X, or it can be hero health, whatever. In this case, I'm referring to it as I because we have our I up here in our for loop. So what this does is this adds 1 to I, and this adds 1 to I each time the variable loops, or excuse me, the for loop runs, the for loop loops. So every time the for loop executes its code once, it will increment I by 1, and then it will do the check again. So the first time the for loop runs, I is 0. It runs through the for loop. I becomes 1. It checks to see if it's less than 10. It is, so it continues again. Then I increments, so it becomes 2. Checks to see if it's less than 10. It is, so it runs again, and it goes all the way up to 9. Now you might be like, okay, it stops at 9, so why does it run 10 times? Well, that's because we start at 0. That is simply the reason why. That's just it. Because when we count to 10, we start at 1, right? And then we get 10 numbers when we stop at 10. If we start at 0, we get to 11 numbers if we stop at 10. So we actually stop 1 before 10 to ensure that we still have 10 numbers. So we start at 0, we run as long as it's less than 10, so we stop at 10. Well, we technically stop after 9. And that gives us 10 loops. We're going to see how this is going to improve upon our program on Wednesday, unfortunately, because I got to make sure I get question and answer time in for you guys and pull questions. So what I'm going to do is I'm going to save this for later. I'm going to call this super inefficient program.txt. And we're gonna use that later to make sure that this runs. Big old circuit, because I like to have helpful names. Cool. So now we've got our circuit saved, and we've got our code saved. Well, you guys probably won't have much typed out because, like I said, he didn't have to type that whole long mess like I did. But yeah, now we're going to do poll questions, and we are going to leave it open for question and answer time after that, and then we'll break for the next couple of days. We'll meet up again on Wednesday. So here we go.